everyone. So I'm Andrew. I'm here representing our project about implementing adaptive assessments in a Harvard X course. And this work was in part of a large team, Yigal, Ilia, Glenn, Dustin from my team at VPOW Research, Colin at Harvard X, and Mary Jean Blink with Tutorgen. And so this was a real collaborative effort with my organization, Harvard VPOW Research. VPOW stands for Office of the Vice Provost for Advances in Learning. We're an educational research group that is very interested in doing educational research in both the online space and also the residential space. And our work with analyzing data from edX is a large component of that. We work very closely with Harvard X. We sit on the same floor, and we work with a lot of their course leads to implement new tools like this in their courses, and also help them analyze data that they get from their courses. And also, Tutorgen is a company that we work with for this project who had an adaptive engine that we used in this project. And the course that I'll be talking about that we implemented this system in is Super Earths in Life. And I'll tell you a little bit more about that later. So just a general outline, I'll go over some background, give you some context for this project. I'll spend a bit of time on the implementation, and I'll tell you about some of the results that we got and some future directions for this project. So, why adaptivity? Why adaptivity in MOOCs? Well, because MOOCs are massive, they're open, they're online. More so than maybe the residential classroom, you get such a large, such a large population of learners who are really diverse, and they come into the course with, different intentions, different educational background, and so adaptivity is kind of a way to help us serve these learners more effectively. And so we really want to target for each learner, we want to target them for, their level of engagement that they come into the course, whether it's they want to just come in and browse a couple of videos, or they want to completely certify and get a ID verified certificate and finish the course. Or if they're there for professional development or just there for fun. And and also for competency, you get people from all ages, high school students who are interested in doing advanced coursework, lifelong learners. And so it's just such a huge population and diverse population of learners. And so adaptivity is kind of a broad concept, and so the specific kind of adaptivity I'll be talking about here is problem sequences. And so this diagram shows, pretend each square is a particular problem, and the top part shows for each student, you could imagine them getting a different sequence of problems, and that sequence is dynamically generated based on the student answers that the student has given to previous problems, and perhaps even information that we've gotten before they entered the particular sequence. And then on the bottom is a typical diagram of how problems tend to work out in traditional MOOCs. Each student gets a fixed sequence of problems that they work through. And so about the course, the course is called Super Earths and Life. It's a very cool course, a course about alien life, it's a combination of astronomy and biology, and it launched in October 2016, so this was a while ago. It's already finished. But there's a new course run that just started a few weeks ago, so you can go and take it now. The one that launched in October 2016 is version 3. So there was already a large body of content that was already produced, and HTML content, problems, and a large percentage of these problems were actually not your traditional multiple choice, but actually custom JavaScript problems. An example of which I show at the bottom. Sorry if it's so small, but it's actually a simulation, and you can adjust the sliders in order to move the lines there. And so we wanted a adaptive system that was able to keep our problem content that was authored in edX and take advantage of all the advanced problem authoring and customization features that we had in the edX platform. And so starting out, our scope was really, is this possible? We wanted to serve problems in a dynamically generated sequence, and in particular, edX problems, which was actually one of the key technical challenges here. And so, this project was framed as a MVP pilot study, and we wanted to learn about, what did it take technologically to implement this kind of project? What were the implications for course developers in terms of how they set up the course, setting up the tool, and really establishing the foundation of some future work that we'd like to do in evaluating the effect of adaptive learning on learner outcomes, learner behavior, etc. So I'll talk a bit about the implementation and how it looks in the course. And so this is how it appears in the course. There's your typical edX course interface, and you go to an assignment, and you see, instead of seeing a bunch of problems, you see this, I call it the problem window, and it displays a single problem and gives you some little toolbar that you can, after you do the problem, you click next question, and you get a next question. And so this is kind of outlining a little bit more clearly what part is what. Like there's edX on the outside, and then you also see edX on the inside, and around it is that thin little thing is the kind of an adapter layer, the LTI tool that was embedded in the course. And so I'll tell you a little bit about the minimal UI components that we had. There was a nav bar in the upper left. It's maybe a little hard to see, but basically when you first enter this problem sequence, you see a box that says 1 on it. And once you finish the problem and get a next question, then you see right next to the 1 box, you see a 2 box, and then so on and so on. And it's set up that way because we don't actually know yet what problems we're going to give you, and even like the number of problems that we're going to give you, because this is dynamically generated based on answers that you've given us. And so once you complete part of your sequence or the whole sequence, that nav bar is a way for you to go back to previous problems that you've done before. And so on the upper right is just a running score tally, the sum of all the points that you've earned in that sequence. On the bottom left is a shareable link. This is just the link to the XBlock URL for the problem, and its intention is, if students have, if they have a question, they can copy and paste this link and put it on the forum, and they can get help. And the reason why we did that is because you don't actually have like a static URL that you can reference. And then on the bottom left is the next question button. Once the student submits the problem, they get their problem graded, and then they click the next question to get a next question. And so we wanted, in the style of a typical scientific experiment, we wanted to separate our learners into two groups so that we could evaluate the effect of adding the adaptivity to the course. And so we had an experimental group on the top and a control group on the bottom. And the experimental group is the one that had the adaptive interface shown to them. And the control group just had, in a traditional way, say like 4 or 5 problems that were just vertically on the page. And the implications for course design were actually quite tricky to figure out in order to accommodate having a control and experimental group. We ended up utilizing the content experiment functionality of the platform, where in, say, the A group, which was the control group, we put the problems that would be the problems that they saw, but also the problems that they might not necessarily see, but the adaptive cohort might actually see in those content experiment blocks. And then in the B group, we actually didn't put any problems there. Instead, we inserted a LTI tool in there. And so what the LTI tool tracks is a bunch of XBlock URLs, and it actually draws from that A group and draws the XBlock URL in there. And so here's like the A group, and then on the top is the B group. And so there's 3 components in play here. One is edX, the LMS. There's also the adaptive engine, which I'll tell you about later. And then there's the LTI tool, which kind of acts as the shuttle between the LMS and the adaptive engine. One thing that I might point out is if you see between edX and the LTI tool, there's an arrow labeled data. And that was actually a kind of a technical challenge for us. How do all this adaptive functionality is prefaced on being able to get real-time problem data out of the platform. And so the way we did it is we embedded a bit of JavaScript in all of the problems in the course, not just the problems used for adaptivity, but all the introductory problems as well, even in the control group. And so what this piece of JavaScript does is once you click submit, it actually waits for the grading functionality to grade the problem. And then it's a bit of a hack, but it's what we had to do. We actually just read the score off the page and looked at whether the CSS styles looked like, whether it was like right or wrong. And then based on that, we make a API call to an endpoint that we implement on the LTI tool. So it wasn't actually through the LTI protocol, but rather just a regular API post. And it sends it to our adaptivity web application, which was built with Django and hosted on AWS using Elastic Beanstalk. On the other side was the adaptive engine. This was provided by Tutorgen. It's called Scale, Student-Centered Adaptive Learning Engine, and it uses a variant of Bayesian knowledge tracing to make the activity recommendations. And so the way that we interact with it is they implement 2 API endpoints that we can hit. We can post a transaction, which means basically we send them a message that is something like, here's student 6. They got problem 3 right, and with a timestamp. And then we keep sending them these transactions asynchronously. And then whenever students click the next activity button, then that means Tutorgen calculates based on its current model, current state, current data that it knows about the students, which activity is right for them. And it does it based on, we've tagged all the problems with learning objectives, and kind of behind the scenes, the basic idea of Bayesian knowledge tracing is to kind of keep track of a parameter for, for each student and each learning objective, what's the probability that they've mastered that learning objective? And it keeps them all in kind of a, conceptually, it's kind of like a matrix, and updates these parameters based on the real-time data that it gets. And so to maybe dive a little bit into the details of what actually happens behind the scenes when someone clicks a next question. So in the X block, well, first I'll talk about what happens when they submit an answer to a question. Student checks the answer. The JavaScript detects the score. It makes the API call to our app backend, and then we store that information in our database, and then we forward it on to Tutorgen. The reason why we kind of act as this middleman is because we need to keep track of running tallies of scores for displaying that UI stuff and keeping track of that score. And we also need to keep track of the score in order to do a grade pass back afterwards. And then, so we store that data, and then when they request the next question, so student clicks next question on the nav bar, then we send a request to the adaptive engine that says, we have this student, which question should they do next? And then we get a response. They're like, question 4. And so then we keep track of a mapping that says, oh, question 4 means this XBlock URL. And then we go ahead and serve that XBlock URL inside the problem window, just with a regular iframe. And the reason why that works is because typically if you iframe in some piece of edX content, say like a XBlock, you'll get some error saying, oh, you're not authenticated or you're not allowed to see this. But because they're already logged into the course in that outer edX context, then that iframing in works because you're already logged into the course if you're using this tool. And so, yeah, we serve them the XBlock and then they do the next question. So now some results. So even though this was a pretty, meant as a proof of concept, we actually got some pretty useful data out of this. And I'll give you a sense of the takeaways first and then take you through some graphs. So something, to me, which was a little bit unexpected was, so we didn't actually see a difference in learning gains, but rather we saw something that we kind of interpreted as efficiency of learning. Say, what I mean by that is students tended to do less, students in the experimental group who experienced adaptivity got less questions, but they still showed the same amount of learning gain from from pre to post course. And then some other takeaways were, on the technological side, getting real-time student activity and interfacing with all these different components that need to know this was a challenge. And also more on the course setup and course development side, implementing adaptivity in a course requires actually a lot of work on the content side. That is, you need to have a large amount of new content in order to actually draw from and serve students the right kind of problem, and doing the learning objective tagging as well. And so this first graph shows the orange is the experimental group who experienced adaptivity, and the blue is the control group who just got a regular sequence of questions. And this shows the difference in from the pre-test to the post-test, which we interpret as learning gains that you had because you took this course. And so it's increased for both groups, but the difference between the pre and post, comparing between the groups, was actually not significantly different, which means we didn't like screw up their learning experience. And so the interesting stuff comes when you start looking at, say, like attempts per problem or problems per user. Here, this shows pretty clearly that students make more attempts per problem. And at first, I was a little taken aback. You could interpret this in a couple of ways. One might be, like if they need more attempts per problem, are they having a harder time, right? But the idea here is that they're getting a problem that's a little bit more suited to their current mastery level of that learning objective. And presumably they might be getting harder problems. And so they are, I guess, need more attempts for it and feel you could interpret it as persistence and they're being more engaged. And at the same time, the number of problems that they attempt per module or in the course actually decreases for people who had adaptivity. And so this is where we started to think about efficiency of learning. You are having the same learning gains pre and post course, but you're doing less problems to get that same learning gain. So, and presumably spending less time on the course as well. So some future directions for this course, for this project. So the first major direction that we are taking with this is trying to generalize out the content source interface. And what I mean by that is you can imagine instead of that two component thing where you're interfacing with the LMS and then you have a bridge in between, and on the bottom you have the adaptive engine. Try abstracting out the content source, because we were actually interacting with the content source quite independently, really, of all of the LMS specific stuff. And so you could imagine this is also related to some of the JavaScript issues that I was telling you about before, where instead of embedding some piece of JavaScript that read the UI content, which may not be ideal due to future UI changes that you might have heard about in a previous workshop, and also because the JavaScript call sometimes, depending on the user's browser's settings, users may just block JavaScript, or because it's making a cross-origin domain call, it looks like a security risk or something. And so we've seen instances like less than 1% where this JavaScript call actually fails. And so this is something that we'd like to fix by actually, as our content source, using OpenEdX as a LTI provider. So we come from edX, or maybe even OpenEdX, and inside the problem window, they're actually seeing content possibly from a different platform. And then you can abstract this out even more. Say instead of OpenEdX, you could use this with other external components. Again, the three components are the LMS, the adaptive engine, and the content source. And so you could imagine there's a set of code that's kind of common to all of this, but there's also interface-specific parts of the code that you could write for individual LMS, individual or different content sources and different adaptive engines. And from the perspective of trying to study adaptive learning, something that we want to do is to kind of interface with multiple adaptive engines and try out different algorithms to see which one kind of works the best. And I guess streamlining course integration and setting up this experiment was actually quite a bit of work and technical work at that. And so we'd like to move towards streamlining this whole process of setting up a course to enable adaptivity. And one possibility might be implementing like a API or UI for say course developers to interact with in order to manage the problems that they have and the learning objectives that are associated with those. And so we are already actually deploying this in the next run of Super Earths in Life, which started just a couple of weeks ago. So you should take it and try out this adaptive functionality for yourself. And we're actually also partnering with Microsoft to test out this, an improved version of the adaptivity bridge and also our own adaptive engine in 2 of their courses, Data Science Essentials and their Excel course. And finally, so as part of this effort, we're trying to organize like a small open source adaptive learning workshop. And so this project, the LTI tool that I told you about in this talk is all open source. I actually forgot the GitHub URL, but you can go there and look at my bag code. And so the workshop is next week, and you can join in person if you're in the Boston area, or virtually via Skype. It's 11 a.m. to 2 p.m. EST, and you can contact my colleague Yigal Rosen if this is something that's interesting to you. So that's all I have. So we'll have to take questions.
So just to understand how you integrate this into the course, very usually we have, with the content, with the videos, very usually we have, week 1 videos and then exercise 1, then week 2, exercise 2 weeks. And I suppose you don't mix exercises from different weeks based on different content. So is this just for one piece of content, or do you do this for every week with a bunch of problems that students have to do?
Sure. So there were, I guess, 16 units in this course. We implemented, because this was kind of like a proof of concept, we implemented this adaptive functionality in 4 of those 16 modules. And for each of those 4 assignments, they were implemented in assignments that came at the end of the module. And for each of those assignments, they all drew from a separate kind of library of problems for each of those 4. So there was a set of, say, 10 to 20 questions for module 1, a totally independent set of questions for module 2, etc. And you can imagine maybe they could draw from the same content library, or you could define kind of partially overlapping subsets. And so, but this was just how we implemented it for this course.
And do you plan to have some adaptivity also to the content? Like depending on what the student answers, you are sent back to some extra lecture or whatever?
Yeah, I think that's a really exciting direction. And actually, because the way that we showed the content was through XBlock URLs, I mean, pieces of content are XBlocks and have XBlock URLs as well. And actually, we did do some content display in this implementation. Problems were tagged with either easy, medium, or hard based on their difficulty. And for some of the more advanced questions, there was some associated content for that question. And so the way that we implemented it was that if the adaptive engine determined that, oh, you should be seeing this advanced content, we'd actually show you the complementary piece of content before that. And the way it looked, I don't think I had a picture in this deck, but in the nav bar, if you encountered a HTML content block instead of a problem, it would color it blue to kind of indicate that that was a HTML content to make it easier for you to find.
Why did you choose to do the implementation as an LTI tool and not like a platform feature? And the subsidiary question to that is, are you aware that there is actually an implementation as a platform feature coming up? So how do you plan to interact with that?
Mm-hmm. Yeah, I've seen some of the work that OpenCraft has done for the adaptive XBlock. Although I think the challenge was first, or maybe to give a bit of context, before this project, I was actually working on a separate LTI project for Canvas, our residential learning system. And so it was, maybe it was a little bit trivial, but it was just a more, maybe more familiar way of implementing it for me. But also, we anticipate from that I was showing in this slide, trying to expand this to use in other systems, other LTI compliant systems like Canvas, which we use residentially. And so we'd like the work that we do here to also kind of flow back into our group's interest in residential learning as well. So thank you.
Thank you, everybody.